Hello everyone, welcome back to more, was it SIS-1? SIC-1. I looked at the video, the last video, I guess. And I noticed it didn't all quite properly fit on the screen, which is kind of a bummer, but also you weren't really missing anything because we weren't using the bottom or the right sides of the screen. So I'm just going to let that video go up as is rather than like give up on the whole recording and never upload any of it. I couldn't capture this program the same way I do most things because it's a Microsoft Edge web view and not like a game. I guess. I don't really understand computers. But we're having fun with this so far, so I'm gonna do at least this episode, and maybe more after that, who knows. We need to learn to multiply. Great. And there were some hints in our email, but like honestly, who needs hints to multiply, right? So, two non-negative numbers. So let's say start is our main loop, and we're going to have an inner loop in there that's like adding or multiplying or whatever. I'm going to have to read into what do you call the inputs to a multiplication, right? For additions, we have like the addend and the summand. I don't really know which is which. I think the addend is what you add to the summand or something. Am I crazy? Let me look this stuff up. Addition, addend, names. The addends are both okay. They're both called addends. What is a summand then? Is that what you get when you add them up? No, a summand is a quantity to be added to another. Something which is added or summed. Well, here it says summand also means both of them. Okay. Names of inputs to multiplication. Multiplicand and multiplier. Okay. So, oh yeah, that makes sense. So the multiplicand is, I mean, they're both kind of the same, but you can think of the multiplicand as like, I choose to think of the multiplicand as the kind of thing we'll be adding to itself over and over, and the multiplier as how many times we will be doing that. In a pure math sense, they're the same. In the algorithmic sense of like a specific algorithm for multiplication whereby you add something multiple times, there's a difference and it's nice to keep them straight. So let's say I mean, can we just call this product? Not really. I don't know, maybe. So let's say product is data 0, I don't know. Multiplicand is data 0, and multiplier is presumably also data 0. We need 3 bytes for our program state. And what order do I get them in? I guess it doesn't matter. I can just choose to. They're the same as far as the specification is concerned, so I can just read them in whatever order I want. So let's write into multiplicand from input and into multiplier from input. Now we have at loop, right? Which is where we actually do stuff. We could, I suppose, save some time here if the multiplier is ever 0 by jumping to an instruction that just writes a 0 to the output, right? and replaces multiplicand. Actually, wait. I can't easily do that because I can't detect zeros instantly. Right. Well, but I can... I can sort of detect... I don't know. Let's just leave that alone. So in the loop... Well... I want right away, before I do any more moving around of stuff... I mean, I might not actually need multiple... I might not need... No, I do need the product of the multiplicand to be separate. Yeah, that's true. So I feel like the first thing we want to do is check if the multiplier is 0. Or rather... We have negative of the multiplier here. And... I guess I want to add 1 to it and see if that result is positive. Because if so, then it must have been negative. It must have been 0 earlier, right? So let's say at 1. To add 1, I need a minus 1 that I can subtract. So subleak into multiplier. Well, should I label it 1? I mean... minus 1? Okay, sure. So subtract minus 1 from the multiplier. And if it's... If the result that we get is less than or equal to 0, then there must be more steps to do. So let's say more. I don't know. Now, if we didn't jump to more, then we're done. We should not add any more copies of multiplier to product. And product is going to be, I presume, storing... Ugh. I guess product is going to be storing the actual product that we want and not its negation. Which means we'll have to negate it on the way out. Because multiplicand is a negative number. And we're starting with 0, right? And we'll be subtracting the multiplicand from it. And the multiplicand will be negative. So we'll have a positive number here. So I guess we need to take... We'll call this, output or something. I don't know. Even though we're never going to jump to that label, it's nice to have it. Our product is positive. So we need to have a 0 that we can subtract from. So let's say at 0 is data 0 as well. Subtract into 0 from product. And then subleak into output from 0. Subleak 0, oops, at 0. Why do I have to write these ats, by the way? Anything that's not a number must be a label. There's nothing else it could be. Why do I have to write the at sign? Did I forget? Is it not necessary? Labels. at name, yeah? Huh. I guess you have to write it. It seems insane. So we'll empty out the 0. And I think we have to empty out some more things, right? Subleak of product. Multiplicand needs to go. Subtle seek. And multiplier needs to go as well. And when you're done, go back to loop, I think. This feels a little painful. It's everything you do in this language, you end up like mangling all of the only way to do anything is to mangle all your variables. So, okay. So if after subtracting -1 from the multiplier, we did not get a negative number, or no, shoot. No, yeah, if we right, if we didn't get a negative number, then we fell through to out. But if we did, then we must have jumped to more, meaning we need to do a step of multiplication, which will be very easy, right? We will subleak into product the multiplicand, right? And that just as a kind of a funny little optimization. If this produces something less than or equal to 0, then we know that multiplicand was 0, and we could short circuit early, I think. To write out a 0? Could we not just jump to here? Out 0? The funny thing is we actually don't need most of these cleanup steps, right? So we could, at the very least, put these up here. And in fact, if I make subtracting from 0 the one that... Or no, I do need actually to clean up the multiplier, don't I? Right, but I don't have... That doesn't have to be the loop step. Wait, does this even matter? Okay, this step is unnecessary, but I don't know how to avoid it. I guess I could skip over to clean mult. If writing to 0, if writing the output was less than or equal to 0, then we know there was a 0 in 0, and we don't have to clean it up, right? So clean mult, like that. Since jumps are free, but executing any other instruction is not free. It sort of behooves us to be a little careful about the order in which we do things. Yeah, we don't need to do this if we're jumping from here, because we found out multiplicand was 0. Likewise, product was 0. Alright, well, this should be interesting. Let's see if any of these assumptions were right. These micro-optimizations, while I don't even have a correct solution yet. Okay, so we found that multiplicand was not 0. And we've decreased... We've added to the product once, right? So can I not just do this? Go back to the loop step? Let's see what happens. So I've stored -1 into the multiplicand, and the multiplier is 0. That makes sense. So what I'm about to do is subtract from the multiplier -1. Oh, and the multiplier became 1. I forgot to account for what happens if the multiplier is... Well, wait a minute. Oh no, this is right. The multiplier... So I claimed we would jump here only if multiplier is now... This is right. Multiplier is now positive, which means it was negative. It was 0. So this is correct. This is what happens if multiplier was 0. Okay, good. So... Wait. We took the negative product and put that into 0. Now we're zeroing out product and multiplicand. We're writing to the output the negative of what's held in 0, which is going to be correct in this case. And it turns out that what we wrote was a 0, so we knew there was a 0 in there. We don't have to do this step. We do have to do this, erasing the multiplier. Now, I think in principle... Yeah, that is true, because multiplier is 1. Yes, okay, fine. Are all my variables right? They actually do look right. So that cleanup went as expected. Oh, not to loop, but to start, though. Because we want to do the next number. Good. Now we're reading the multiplicand and the multiplier. The multiplier is -1, so we don't start outputting. We subtract from product the multiplicand, which is 0, and we detect, hey, wait a minute, all these zeros are going to do nothing. So we can just output a 0. And we don't have to clean up 0 because we didn't mess it up. We just overwrite multiplier, which happens to be 0 because we were multiplying 0 by 1. But if we'd been multiplying 0 by 5 or something, this cleanup would be necessary. I guess we could have this jump to somewhere other than out 0, and it would be 1 cycle faster. But it would require writing more bytes, which I'd rather not. Or a longer program or whatever. So now our first real multiplication, 1 times 1. We actually went to more, and we put a 1 in the product. And now we're going to add -1, or add 1 to the product 0 times, and that should be correct. Yeah. Now what? 2 times 3? Okay, our first exciting one. So we should be adding 2 3 times. That's a 2. 2, and it all gets written. Okay, I think we're done. Great. Cycles executed more than average, which I'm a little surprised by. I must have done something wrong, because I feel like I was being extra careful to, like, not do unnecessary cleanup, but okay. And below average on bytes read, which I felt I wasn't really optimizing for. I noticed it, well, one thing that's not clear to me yet is, does bytes read include instruction bytes that you read, or just data bytes? I don't know. But who cares? You're Pat, another engineering lead. I've been making good progress. You want to help me improve morale, so if I like something or don't like, just let you know. Suspicious. SIC Systems sanctioned computer video game called Avoision. If you think your work would benefit from an entertaining diversion, please feel free to go for high score in Avoision. You can find it in the diversions section of the program inventory. Okay, well, that's interesting. Use the arrow keys or WAS to move your block and try to capture the bright green square. The faster you capture it, the more points you get. As you progress, moving dark green blocks will appear. If you collide with it, okay, I mean, sure. So I'm supposed to go get this, is that right? I see. Well, this isn't quite the same game as what I was playing a second ago. It is a bit like playing in traffic. So far, not hard at all. And I guess there's no time scoring, it's just number of blocks picked up before you die. I imagine this gets tricky eventually. I almost killed myself 3 times there? Okay. I was saying I imagine it gets tricky. New high score, yes. How do I... Hello? Do I have to click here? Wait, so what is my score? Why did I get 156 for doing 10 things? The faster you capture the square... Okay, I thought it said that. I didn't see that on the screen, but... Oh, I see. At the top left, there's a points marker. And it goes down every second, and every time I touch a square, I get that many points. Can't catch me, I'm the gingerbread man. It's messy in here. I can't keep track of all these objects. Oh, wasn't the high score 240? Am I wrong? 249. Alright. One more try. And then maybe more tries after that. Why would I play a programming game when I can play the Run from Squares game? It's so bite-sized. Well, okay, that was a little optimistic. Is there a button to restart or something? That would simplify my... That would get me back to work a little faster, because I could play more games in the same amount of time. I feel that would be good for morale. Hey, I got that one. Ah! Okay, that's enough. Unless I get 1,000 points for winning. If they give me a raise, maybe they would actually pay me. How do I... Yes, leave... I guess go here? Division. Divide A by B and output the quotient followed by the remainder. I mean, this is basically the same thing as multiplication, right? It's pretty close. Although, here A and B are not interchangeable like they were in the multiplication problem. I mean, I kind of want to go like look at my multiplication program and copy some stuff. Because this is not exactly what I want, but the structure is very similar. Is there like a find and replace or something? I don't know. It doesn't look like it. So, oh gosh, what are the names of things in division? We have the divisor and the dividend, the quotient and the remainder. The dividend is what we're dividing, and the divisor is what we're dividing by. So let's store A should be the divisor, of course. No, the dividend. I was just saying what the difference is. So, great. If... I guess it's a different loop termination condition, right? Sort of? Yeah, because you're meant to just like keep dividing until the dividend is no longer larger than the divisor, or as large as the divisor. Like, I've done this so many times in so many programming puzzle games. Why am I doing this again? Is what is suddenly in my mind. Like, yes, I play these programming puzzle games because it's interesting to like solve these things in different constraints, and I'm sure they'll introduce new like puzzles that make use of these unique constraints. And I mean, I don't know, like multiplication was more difficult than usual because of all the like weird shit you have to do, but I'm kind of like I think I'm about done with this. Is there anything else I should be doing here? Like, show me my program inventory. Like, I'd kind of like to know what might be coming next, but not enough to do division again. Yeah, I think that's my verdict on this game. It's kind of fun to play with. I'm sure it gets, more complicated and just... I'm not getting the fulfillment out of it that I want from these things. I can't blame the game for it. It's exactly what it said it would be. But I think, personally, I'm about done with it. So no division today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.